Hello, back again to our next session. So it's our pleasure to have already the second time Oliver Buhlinger here at our Pharmacircuit conference. And together with him today will be presenting Chetin Gorgulu. So this will be a very interesting presentation about how to make business decisions simple with digital twins. So Oliver, he is the co-founder at New Intelligence Group, which is a business transformation and artificial intelligence startup. And in this section, he will demonstrate us how the benefits of digital twins can bring to pharma companies by optimizing the CAPEX, the OPEX, safety and training, quality, sustainability, and virtually planning in automation and robotics. So I think this is very interesting. So background of Oliver is he is a chartered engineer and with over 26 years of combined experience in manufacturing, software, and life sciences. I think there's little persons around which have this interesting combination of skill sets, and therefore much looking forward about his presentation. Chetin is the managing director of Cambridge Automation Simulation, and basically they make business decisions simple with digital twins. And by doing this, delivering solutions to small and medium-sized enterprises and blue chips companies on a global level. And he will demonstrate us how these digital twins can benefit pharma companies using visual component software. He's an electrical engineer and MBA, and with over 14 years of industry experience, and much looking forward to his insights on the presentation. So the stage is yours, Oliver and Chetin. Much looking forward.
Thank you, Mario. Thank you. It's a real pleasure to be here again this year. Last year, really enjoyed it and really grateful for the opportunity. So thank you to Mario and the Pharmacircuit team. Yeah, we're really excited today, so I don't think we need to do any more introductions because Mario did such an excellent job. So yeah, we'll just try and take you through some of this topic, because digital twinning is such a vast topic that yeah, you just can't cover it in 30 minutes. We're going to keep it really top level, high level, and talk about the benefits, give you some examples, and then actually Chetin will deep dive into one of the software solutions and tools that you can use to build your digital twins. Chetin will build some robotics. I think he'll be using a Stäubli robot, because Rudolf's presentation was great, really good, and I think the two topics fit like a hand in the glove. So if we go to the next slide. So today as an agenda, we will try and cover that. It's quite a lot. Yeah, so we'll just have a quick look at the trends in pharma, then we'll talk about digital twins and what other people are saying about digital twins. So we'll play a short clip from Siemens, and then we'll look at some of the benefits and when sort of the stages in any project that you might be looking at, whether that's in developing a factory or a lab or an automated lab or any processes, at which stage should you think about using digital twins or simulation. And then a quick slide about a little bit more about us and what we get up to. And then we'll touch on not a pharma project that we've delivered to a customer, but something in the industrial process industry about how to repair pipes. But it's just to show how simple digital twins can really communicate a message. Then we will look at virtual commissioning, which is one of the bigger benefits of using digital twins, because it's about how quick can I get a line implemented, commissioned, and using those tools.
And without hassle.
Without the hassle, right? Yeah. And then we'll go into visual components. So Chetan will build a quick layout and take us through our latest project that we've just completed and we're really, really proud of. And it's with a very innovative UK system integrator and pharma solutions provider, Industrial Technology Systems, ITS. So it'll be really exciting. Right?
Yeah. I would like to show you briefly what's the power of visual components at that stage, and we'll show you what you can do by yourselves. And then, I'm going to present you the latest project, which we're proud of. Let's carry on.
Okay. Last time Mario asked me this interesting question about the trends in pharma, or a similar question at least. And to be honest, I've just had a quick look around, and it seems that no matter what industry you're looking at, the trends pretty much are mirrored. So of course, the first thing is all of industry, government, and even consumer market all want to digitalize, no matter what it is. And there's no difference in the medical, in the pharma industry. You see here how virtual reality, augmented reality, and holographic technology is employed to help make things more easy, accessible, and available. So in terms of what we have here, the first is how to advance your product and process mastery. So traditionally it was all about utilizing lean and machines, but now you have the ability to virtually validate your processes, your factories, your labs, your machines, and it even goes down to the things like the technologies that we've seen employed more recently and during the pandemic, CRISPR and all of this advanced technology utilizing AI and machine learning. So again, it's about having the information available immediately in real time, being able to be proactive about how you manage your operations, and turning data into information using business intelligence. Again, AI is a strong player in that, and predictive simulation, which is something we are doing. So this is about connecting almost everything to create scenarios of what future outcomes could be like, and that could be using offline data or real-time data. Then we have the end-to-end simulation and optimization, and this is really about where you use a digital twin or a simulation model to look at an end-to-end process. So not something discrete, like maybe one robot cell inside of your production facility or lab, but actually looking at everything that happens from the first interaction with a customer through to what happens in the transactional processes in maybe, say, supply chain, engineering, skills, your preventative maintenance, and then the movements of products in the business, and the supply chain, as I said, and then what happens in the field. So you can actually have an end-to-end twin of your complete value chain, or your whole business, or your whole ecosystem. So beyond your business to your customers and suppliers. And that is a big push. And then, of course, robotics, as Rudolf just covered, is a big player in pharma and everywhere else. And it is about automating production. It's about eliminating non-value adding or repetitive and laborious tasks, and freeing up humans to actually focus on more important stuff. So, as much as some people have the fear that the robot is going to replace me But if we actually pivot and sort of shift where we train ourselves and what we get involved in, then there's a big opportunity. The robotics, the introduction of these technologies actually creates more jobs. Might be different jobs, and it might be that you just focus on something more important and let the robot do the boring stuff. And then the real big thing, as we see up there as well, is the augmented reality, virtual reality, the Internet of Things, connecting everything. We now have 5G, and it is about assisting the operations digitally. So this might be training a surgeon or giving the surgeon the ability to carry out the procedure virtually before they carry it out on the human. It might be training people in a certain procedure that need to be executed in the lab, and they might have some augmented reality glasses on, and they get the instructions of what they need to do in real time. So it basically, in a simple nutshell, it's Industry 4 is the paperless shop floor. It's the paperless business. It's paperless world, I guess. So what is the digital twin? It's a virtual representation of a real world system. Next slide, because of time.
Mm-hmm.
So what does Siemens say about it? All right, next slide.
Of course.
So the cost benefits could be in the millions when you're looking at proving virtually before executing. So some of the digital twin projects have delivered us over 2 million of cost benefits, and it's making things quicker, faster,
Safer.
yeah, shorter development times, and getting more out the other end. I think that operationally, using digital twins and simulation, you can get more out the other end, and that's really, and it's optimizing all of the other KPIs that you have in a business, and even people metrics that go up.
When shall we start to create our digital twin? Honestly, it should start at the beginning and where you can get the most benefit. I mean that at the concept stage, while you are designing anything like a clean room or a workshop or want to automate something, you can start twinning it. Then you buy some time to not to losing detailed CAD files or extra engineering it, because you may find out big problem in your workflow design or another place. And once you jump to other stages like design completion and planning, your banking is getting lower because you spend a lot of time, maybe money, And if you find out a problem in the other stage, like planning and manufacture, you have to bear big cost. And also the commissioning gets another big benefit because if you are virtually commission your system, you don't have to build entire mechanical system because you've got your twin, which is the digital replica of the whole system, and you can validate your own PLC or whatever controller you are using into the digital environment. Then first you'll validate your bugs in the code, and you'll check your safety functions if they are working or not, and you can save maybe the lives, I don't know. And you can avoid yourselves higher risk, very big risk, and you can shorten your delivery times and your project times. Most of the project, 20% of the last 20% of the project, which is maybe the commissioning, most of them takes longer time and the budgets.
Yes, excellent. Yeah, okay, next slide. And yeah, we as a team, we specialize in digital twins. As you can see, Chetin has been adopted by the Gates Foundation. So it's something we said that we were going to this is a project we can't talk about, but Chetin has been involved in some amazing aerospace projects as well. We have won the Operational Research Society President's Medal. We regularly present at conferences, and we also won the Smart Factory Award. But one of my proud moments still is that using digital twinning actually got me in front of a royalty. So the products that you see there in that corner, they were all proven, the value and the benefit to the business as an 400K project was validated through a digital twin, and that resulted in us building a complete twin of the factory or the business, and yes, touch of royalty. Right? So a very quick one, because I want to give Chetin as much time as possible. So this was really, this is not a connected twin, it's more of a visualization for marketing for a business that is part of a European consortium, and our customer was MCS Control Systems, and they are system integrators to industry, and they delivered the control panels of this fast fit, no-dig robotic pipe repair solution, and we delivered the digital twins. If you go hit the video. So the advanced visualization tools were really beneficial to the project, and this is just the first stage of going on this digital twin journey of a simplistic to the next stage being that you use this a twin of the product to show the benefits and actually use it to then connect to it during the operations. And then, you know, when you are a startup that has produced a solution, you know, when you get to the scale up phase, if you're already on that journey, when you scale up, you can use what you've built already and then go to the next stage to use that and build a twin of your facilities to scale up your production, your manufacture. And eventually you'll just, naturally there's this evolution of a digital twin or simulation professional that says, well, why don't I connect it? Why don't I make it advanced? Why don't I let it think? Why don't I let it make decisions? And yes, over to you, Chetan.
Yeah, visual components. While creating these digital twins, this is the tool we are using mostly, the visual components, because it's a brand independent tool. What I mean with the brand independent, because it has a powerful library, which I'm going to show you in a couple of seconds. And it includes almost all the automation products, starts from the conveyor, robot tools, robot from not only the European brands, from the America, Far East, and on top of this, you can not only create your layout, you can test your layout, you can test collisions, you can create your entire factory if you want, and then you can test your throughput or safety, and at final you can virtually commission not only the robot but also the machines. You can merge them together, create your workflow, and test your entire workflow or virtually commission your entire workflow, because the virtual commissioning are mostly perceived as a robot commissioning, but it is more than this. You can virtually commission your entire cell, entire workflow by using digital twins.
You have to jump into your...
Yes, and then let's make some simulation to show you the real platform. So I jump into my PC. And
no pressure here, Chetan.
And I think, yes, I need to add presentation for a while. This, yeah, it's coming.
Okay, are you going to use a Stoibli robot in honor of Rudolf?
First, I want to show you the library in here. This is the interface of the software. And in here, you can see a lot of models comes as standard with the software, and they are, you can have feeders, different types of conveyors, and these are parametric components. And you can create your system like drag and drop to here, and you can go here. When I drag and drop, yes, they automatically connect each other, and this is as simple as it is. And when I take this one and make it bigger so everybody can see, so it immediately starts working. It's just a simple conveyor feeding system, and everything starts with this. And then you can create your flow, products, everything, and put your resources. Let's do a simple pick and place, then jump into the real project. What I'm gonna do, I'm gonna pick a robot, and yes, we can search brands in here. In the library.
STAU, I think.
Yeah, if you can't write the right manufacturer like I did, you can also just select them by refresh. Another advantage of having the WAS library is it's a connected library. Once a new component is being added, it's update itself. So let's find the S in here. Maybe you read the brands.
Bit more.
Yes.
There we go.
Yeah, I found it.
Excellent.
pick something big. Yeah. Oh, it's paint. Yeah, pick this one. Yeah, it's put it in here. And another advantage of this one is you don't have to be a robot expert. You can and you don't need a very complicated skill set to use this software. Put here. Because if you don't need a very complex programming in your workflow, you don't have to program the robot, because in normal cases there is a pre-written automatic codes inside.
Okay, I think you've got 1 minute left.
Okay.
I'm not sure when we're.
I hope I can finish.
No pressure.
Oh, yeah. Make it a bit closer. The only thing I need to do, I need to define my flow like this from here by using this from there. And fingers crossed.
Wow.
And at that amount of time, we can create a simple pick and place cell. And then, if you can spend enough time on it, limit is.
Chetan, I think we need to jump to the ITS.
Yes, I'm doing right that one.
Ah.
Yes, and then wheel. You can have a cell like that complexity, but honestly, not in a couple of seconds.
Yes. So yeah, I think one of the trends as well in pharma and some of the projects we've seen is this localization of manufacture, because in terms to comply with environmental and the sustainable development goals, really, you need to try and limit transporting materials, medicine, all of these kind of things. And localized manufacture is perfect. So, where you can almost put a factory into a small facility rather than one giant facility somewhere else. If you jump to the PowerPoint, and then we'll show the short video of that project.
Yes.
If you jump straight to the
It's coming. Yeah.
It's not the next slide. Next.
Yes.
Yes. So yeah, I think we've run out of time, but we're really excited about working with ITS, and this is one of the solutions they provide, and they provide system integration and technology solutions to pharma, and this is really to showcase their capabilities, and this is basically a make-to-order process where it's very there's almost no human interaction there, where you can have an order for a specific person configured in that production line, packaged, labeled, the
control checks, and then there is a very tailored robot tools over there to pick the wires, scan them, and there's a lot of complexity in real life. And you can overcome all this complexity by the twin, like virtual commissioning, proof of concepts, because there can be easily collision there. It's a blank space. Yeah, we can say a lot of problem in a second in here.
That's it.
Possible problems.
That's it. I think we're good with time. So thank you very much.
Thank you very much.
I really appreciate it, and I hope this short demonstration was helpful. Well, if you go to the next slide, if there's any questions.
So thank you very much, Oliver, and this has been quite insightful, your presentation. So I think it's obvious, of course, the pharmaceutical field is of course a big playground there, and also as as development cycles and capital investment, of course, are quite high in this industry. It's quite regulated. So I think that there's a lot of room for digital twins. So it has been very insightful, Jet and Oliver. Thank you for showing us that. So I'm quite impressed. So out of curiosity, how do you achieve that to capture accurately all the physical properties of such a immense, let's say, volume of data? I suppose. So how is this done?
Yeah, it's a process, but in the tools we are using, we can model the real physical assets into the twin, like individual components. There's an open API, and we create all necessary features which link to the data. For instance, the digital signals or a data page number, whatever you need, it's been processed in this simulation, like the visual components. And that all the process you see in here run according to the real workflow, as it should. And then once we play with these parameters, it's going to generate us a real results.
Yeah, I think there's a lot of work being done. So when we step back and think about a fully connected business ecosystem, there's a lot of work required when you want to have the accurate data to connect to, but also you need to really, the organization needs to be ready and capable for that advanced connect to everything, and there's a lot of work being done and standards to actually unify all of the different data sources to enable that. So there are fully connected digital twins of full end-to-end businesses. They are still far and few between. We are, we as a team are one of the few people to actually have done it. But yeah, as Chetan said, on smaller discrete cells, it is actually very, very not, I wouldn't say easy, but it's possible to take all of those data sources. But you always, I think this is one of the main sort of barriers in some cases where people won't adopt because they say, oh, my data isn't clean, my data isn't accurate, or there's too much data volume. But it's always try and simplify the complexity and start somewhere. And in most cases, we actually use digital twins to clean the data up. Because if you use these tools to visualize, you can then much easier check what might be wrong in your source data.
Yeah. And all of them is also scalable. And when we start small, as Oliver said, we can scale up the entire factory. You don't have to start from all factory. You can pick a point, or keep this process running, and then if everything's okay, you can apply this approach, another one, and add them, stitch them together.
Yeah. Thank you very much. So very, very insightful, very interesting. So much looking forward, and also to all the listeners. Of course, you can contact with Chetan, with Oliver, over the networking, or over after the event via LinkedIn or the contact data. If you're interested in them, please let us know. So thank you for joining today at Pharmacircuit. And has been a pleasure in having you, and quite interesting and learning about these digital twins. So I'm quite impressed by your work.
Thank you.
Thank you.
Looking forward to the rest of the event, and enjoy it. And thank you, everyone.
Thank you. And so to the rest, we will be back in 4 minutes with the next session. So we will just briefly disconnect and then connect back in 4 minutes with the next session. So thank you, both of you, and looking forward to the rest of the day.
Thanks. Bye.
Bye.